let's start with a warm-up ratio problem. Then we can tackle some harder word problems. So I have the ratio 13 over 6 is equal to 5 over x. So one thing I don't like having this x in the denominator. So what I want to do is let's multiply both sides of this equation by x. So if I multiply both sides by x, what's going to happen? On the right-hand side, this x is cancel out with that x. And then the left-hand side is going to become 13 over 6x is equal to, you're just going to have a 5 there. And then to solve for x, you just multiply both sides by the inverse of 13 over 6. 6 over 13. 6 over 13. These obviously cancel out. That's why I multiplied it by the inverse. And you get x is equal to 5 times 6, which is 30 over 13. Now, one way that you might see this done, it's kind of skipping a step, is called cross multiplying. Where you look at a ratio like this, and you immediately say the numerator on this side times the denominator on that side is equal to the numerator on this side times the denominator on that side. Let me write that out. So you might sometimes see people immediately go to, let me just rewrite the problem actually. So the original problem was 13 over 6 is equal to 5 over x. You might sometimes immediately see someone go to 13 times x. 13 times x is equal to 5 times 6. And it might look like magic. How does that work? Why does that make sense? And really, all they're doing to get to this point is they're simultaneously multiplying both sides of the equation by both denominators. Let me show you what I mean. If I multiply both sides of this equation by a 6 and an x, what's going to happen? If I multiply it by 6x times both sides of this equation. And where did I get the 6? From here. Where did I get the x? From there. Both denominators. What's going to happen? On this side of the equation, the 6 is going to cancel out with this denominator. And on the right-hand side of the equation, the x is going to cancel with this denominator. So you're going to be left with 13 times x is equal to 5 times 6. So nothing fancy there. You're just multiplying by the denominators of both sides of the equation. And it looks like you're cross multiplying. 13x is equal to 5 times 6. And then from here, of course, you divide both sides by 13. You get x is equal to 30 over 13. Now that we're all warmed up, let's tackle some actual word problems. So we have the highest mountain in Canada is Mount Yukon. It is 298 over 67, the size of Ben Nevis. All right, let's y for Yukon is equal to 298 over 67, the size of, let's say, n for Nevis. That's what this in green tells us. The highest peak in Scotland. Mount Elbert in Colorado is the highest peak in the Rocky Mountains. Mount Elbert, so we have this other information here. Mount Elbert is 220 over 67, the height of Ben Nevis. So let's say E for Elbert. E is equal to 220 over 67 times Nevis, times the same Ben Nevis right there. And they're telling us more. And it is 44 over 48, the size of Mount Blanc. So Elbert is equal to 44 over 48, the size of Mount Blanc. Let's write B for Mount Blanc. They also tell us Mount Blanc is 4,800 meters high. Mount Blanc is 4,800 meters high. So B is equal to 4,800. And they ask us, how high is Mount Yukon? So we have to figure out why. So let's see if we can work backwards and figure out all the variables in between. So let's start with this information here. B is equal to 4,800. E is equal to 44 over 48 times B. So Elbert is equal to 44 over 48 times Mont Blanc, which is 4,800 meters. Now, if you divide that by 48, 4,800 divided by 48 is 100. So Elbert is 44 times 100 meters high. So it's equal to 4,400 meters. Fair enough. Now we can use this information and substitute it over here. We get Elbert, which is 4,400 meters high, is equal to 220 over 67 times Ben Nevis, right? N for Nevis. To solve for Nevis, we multiply both sides by the inverse of this coefficient right here. So we multiply both sides by 67 over 220. So times 67 over 220 times 67 over 220. This 67 cancels with that 67. That 220 cancels with that 220. And then you get, let's see, if I take 4,400 divided by 220, 440 divided by 220 is 2. So this is going to be 20. So 4,400 divided by 220 is just 20. So you get Nevis is equal to, I'll swap sides. So Ben Nevis is equal to 67 times 20 meters. And that's like what, 1,340 meters. So is that right? Well, let's leave it like that because we could actually, it looks like that 67 is useful. So I'm going to leave Nevis as 67 times 20 meters and substitute it right there. So Yukon, I'll just go down here so I have more real estate there. Yukon is equal to 298 over 67 times the height of Nevis. Nevis is 67 times 20. So times 67 times 20. Well, I could divide 67 by 67, and I get Yukon is 298 times 20 meters. So Yukon is equal to 298 times 20. And what is that equal to? That is equal to, we could just, let's see, that's 2 times 298 is going to be 396. 390, oh, sorry, it's going to be 596. 596, this is almost 300, so it should be close to 600, right? This is 2 less than 300, so this should be 4 less than 300. And then I have a 0 here, so it's going to be 5,960 meters. And we are done. Let's do one more of these word problems. All right. At a large high school, it is estimated that 2 out of every 3 students have a cell phone. And 1 in 5 of all students have a cell phone that is 1 year old or less. All right, so let's think about it. Let's say that x is equal to the total number of students. The total number of students. This first line, 2 out of 3 students have a cell phone. So we could say that 2/3 x have cell phone. Have a cell phone. That's what that green statement tells us. And then that purple statement, 1 in 5 of all students have a cell phone that is 1 year old or less. So 1/5 x have less than 1/5 year cell phone. Cell phone. So they want to know, out of the students who own a cell phone, so out of this, that's our denominator. So let me write that down. That is our denominator. So out of the students who have a cell phone, that's right there, they want to know what proportion owns a phone that is more than 1 year old. So how many students have a cell phone that is more than 1 year old? Well, we could take the total number that have a cell phone, which is 2/3 x. 2/3 of all the students have a cell phone. We can subtract out all of the students have a new cell phone, of a cell phone that is less than 1 year. Remember, they're saying more than 1 year here. So we want to subtract out all of the students with the new cell phone, minus 1/5 x. And you will then have the proportion of students who have this right here. This is right here. This is have greater than 1/5 year cell phone. They have a phone, but it's more than 1/5 years old. This is all of them that have a cell phone. We subtract out the new ones. So this is essentially all of the people who have an older than 1 year old cell phone. So to solve this, we just subtract the fractions. So this is just going to be, let's see, over 2/3 is the same thing as 10 over 15. That's 2/3. Minus 1 over 5 is the same thing as 3 over 15. X, which is equal to 10 minus 3 is 7 over 15x, is the total proportion of students. That's this orange. What proportion owns a phone that is more than 1 year old? It's 7 over 15x. That's the actual number. So if you want to know, out of the students who own a cell phone, so out of the students who own a cell phone, right there, 2/3 x, what proportion owns a phone that is more than 1 year old? This is the number that owns a cell phone that is more than 1 year old. And this whole value is the proportion out of the students who have a cell phone. Lucky for us, the x's cancel out. And we are left with, this is equal to 7 over 15 times the inverse of the denominator, right? When you divide by 2/3, that's the same thing as multiplying by 3 over 2. And what is this equal to? Divide by 3, sorry, divide by 3, divide by 3. We are left with 7 over 10. So of the students who own a cell phone, 7 out of 10 of the students who own a cell phone that is more than 1 year old. And we are done.